Hello everyone, it's April the 10th. Let's see how we have. I'm most likely not gonna do this, so prepare to just copy and paste. I'm ready to copy and paste. Count a number of powerful integers. 3 integers, start, finish, and limit. Start, finish, and limit. You're also given a 0 integer string representing a positive integer. A positive integer x is called powerful if it ends with s. In other words, s is a suffix of x, and each digit in s is at most limit. Return the total number of powerful integers in a range start to finish. Okay, read again. 3 integers, start, finish, limit. Okay, start, finish, and a limit. You're also given a 0 index string, s representing a positive integer. A positive integer x is called powerful if it ends with s, so s is its suffix, and each digit in x as at most limit. So limit is 1 to 9. Start to finish, and s dot length is log finish floor plus 1. Okay. S only consists of numeric digit which are at most limit. Oh, S only contains digit that's the most limit. S does not have leading zeros. Okay, so we have 124 as a suffix, and your limit is 4, which means that each position you can pick 1, 2, 4. Oh, we can pick 0 too, right? Limit is 1 to 9. Wait, hold on. I think 0 is not allowed. I can just do examples, right? So 6,000, which means I cannot do more than 1. So I can only do 1, right? And I can do 1, 2, 3, 4. Yeah, 5. Oh, 1, 2, 1, 2, 4, which means essentially this is 0. Alright, second one, start. So we need to end with 1, 0. And it has to be 3 digit. And most, so this position, right, we can do 0, which will give it 10. Oh, but 10 is, yeah, 10 doesn't work. So now we got this digit, so we have basically 1 and 2. That's it. I think this one I want to try, because if 0 is possible, if like we do, you know, like call it 10,000, finish is 10,000, okay? Finish is 10,000. That means we can add this one. right? And of course, start is 1, so I'll have all these 5. Basically, it's 0, 1, 2, 3, 4. Oh, holy crap. Oh, 5, 6, all the way to 9. Right, and then we'll have 10. Oh, let's do 20,000. Right, we'll have 10. So we'll have this is we'll have 10. And then we have 10 all the way to 19. That's another. Oh, limit is 4. My bad. Oh, bunch of requests. So this will be 5. So this to 14. That's also going to be 5. And that's it. 20 we cannot do because this. So essentially this one, the expectation is it shall return 10. So that will tell us 5. Oh, I didn't change. 20,000. Yep. So 0 is allowed. Okay, so we have a suffix, right? So apparently, first thing to consider is what's the most number of digits we can add? You know what, I think I'm gonna Python this, which will probably save a lot of trouble, a lot of hassle. So we looking at, well, okay, first things first, I need to compare this to the start, right? If we are start is actually fine. It's just the max, the finish. If this is bigger than the finish, then yeah, it's not gonna work. So okay, that's the first thing. We're gonna check on the finish. Okay. So okay, now finish works. So we have a finish which is above you, right? So we have a finish here, which is above you. Then we can find how many digits are there in finish, right? So digits has, I don't know, certain number of digits, and now I can consider, yeah, with some number of digits, so we know what's the maximum digits that we can do, right? Maximum number of digits that we can do. And then we have the starting point. So the number must be larger than the start. So we have a start, right? So we just do by itself. Is it bigger than start? If it's bigger than start, then we have 1 already. Right? If it's smaller than start, smaller than start. I actually want to. I think that's an edge case, right? Okay, so now I'm gonna start to fill. Then we have a limit, right? So we say if the start is bigger than this, probably not. If the start is not bigger than this, then we just keep going. Well, we just keep going. Because if we loop through this, that's only, well, we have the smallest is when it's 0, right? And I'll have the biggest when it's the limit, right? So in this case, we have smallest is 124, the biggest is 124, right? So we will check to see which one, like where the start goes, where the start and finish goes, right? So basically we have a list. We just can't represent it very well because it can actually have a lot of numbers. But essentially we just have numbers, and we have a start and we have an end. We just want to know for start, where should it be, right? Where should it be? Where should the start be? Very interesting question. The start should be somewhere, right? If the start is bigger than this, if the start is the middle, bigger than this and smaller than this. So like if start is here, then everything will be included. If start is here, which means start is bigger than this, is just ignore. We immediately go to the next one, right? So it's when the start is in the middle. Okay, and let's say for the current digit, right? We have a current digit and we have a ranking, right? We have a ranking. It's like now we have like 4 digits, right? 4 digits. Then we do whatever we want. 5 digits. So we have a certain number of digits, right? And we have the numbers. Like we have 3 digits. If the limit is equal to 4, then essentially we'll start from, because this first one has to be 1, 2, 3, or 4. And then the second one can be 0 to 4. This is also 0 to 4, right? So we have bunch. Now what we want to find out is where is the smallest? The start. Where does the start fit in? Start. So I have a start, and I can know like the start, how many digits are in the start, right? Yeah, so I want to find the starting value, so we don't have to worry about start. So if start is smaller than the suffix, smaller equal to the suffix, then we don't have to worry about the start. If the start is larger than, then we need to find out where the smallest one will be. And to find the smallest one, we first notice how many digits are in start, right? Okay, so we know the digit of stars. So if the digit of star is the same as yeah, that doesn't matter. We have the digit, right? And then we want to find the smallest one that's bigger than the start. Okay, smallest one's bigger, so I try to see the first digit on start. Right, if the start and the suffix is the same distance, same thing, then we know the starting will be just we have to do a 1. That's the starting point. Or essentially we don't have to worry about it. Right? If the start is smaller, then we include that. If the start is bigger but with the same digits, then we don't include it, but we start with a 1. Now if the start is much bigger, have more digits, then we check the first digit. Right? We check the first digit of start. If the first digit of start is bigger than the limit, then boom, we can go, right? Basically, we go the start left to right, right? For each digit, we compare, right? Each digit we compare with the limit. If it's smaller than the limit, then we'll take that value. Right, we'll take that value, and we'll go to the next one. Next one, if it's smaller, we'll take that value, right? Okay, next one. If one of them is bigger than the limit, right? If one of them is bigger than the limit, then like at this position, if it's bigger than the limit, that means we cannot cover this one, right? If we cannot cover this one, that means we need to find the previous one to get bigger, and it becomes 0, 0, the remainder. That's the smallest. If we can cover, we'll continue cover. We'll cover this one, and we'll move on to the next one. We'll cover it, right? We'll cover everything. Okay, yeah, we'll cover everything. Now we find the smallest. Okay, now we find the smallest. Good. Now we have the smallest. Yeah, we have the smallest. We say, something, something, something. 1, 2, 4. Right, we have 3 digits. We have the smallest. And then we just need to figure out how many more we have. Because when this digit go big, go to the next one, right? It's +1, then there's no restrictions. You can do whatever you want, right? Okay, they can multiply them. It's fine. But for the remainder, right? For the remainder, it depends on what value it is, and it can only go bigger. Can only go bigger. I think this is the most difficult part. You need to figure out how many we need to go. So, we can say with the current, then we have how many, right? Done. And then we come in here with the next, like, yeah, with this value, if everybody's set, and then we just do this, so we have how many. And now we move here, we can get it a thing bigger, and then we say how many of this times this, right? And then this we say yes, with this set we have whatever, right? Now with this set, this can go, because I already done it, so it has to increase. So we increase, then we have whatever we have, and each one with this, so we can get that with this set. Now we move on to here with this set, right? This +1. There we get whatever we have, and then with this set, this +1, then we find out whatever. So this times this, right? And then times whatever we have. Done. Now we'll go to the bigger one. So a bigger one basically, and the finish can be, the finish, yep, they have to also worry about the finish. Jeez. Well, we can do the same thing, which is the biggest one that's smaller than finish. Right? The biggest that's smaller than finish. So we'll find that. So now we have two bounds. We have the lower bound, we have the upper bound. Perfect. Then what? We have the lower bound and we have the upper bound. Well, we have the lower bound. So like in this case, lower bound will be the smallest number that's bigger. Right? The smallest number that's bigger than, yeah, the lower bound is no lower bound. Lower bound is just, so lower bound in this case is 124. Right? And a higher bound is the biggest that's smaller than 6,000. Highest is smaller than 6,000 with a suffix. So we have a suffix 124, right? Highest, it doesn't matter what it is. So highest, so we can say, yeah, we cannot do 6. Right, so we have the same number of digits, but we cannot, and in this one we cannot do 6, but we do the biggest possible, which is 4. Right? And then we move on to the next one. Like if it's the same, right? If they're the same, we move on to the next one. We try the same thing again. If it's smaller, then we do it. But if it's bigger, or if it's smaller, then yeah, we do it. But if it's bigger than the limit, right? If it's bigger than the limit, then we simply can do it, right? If it's bigger than the limit, say this one is bigger than the limit, then we use the limit, right? Because we want something small. So we like the biggest is, so ideally it's we all use a limit, right? We try the limit on first one, we try limit on second one, and if first one is smaller, then we can just use limit for everything. If first one's equal and the next one needs to be careful, right? We have to compare to it, and if it's smaller, we have to get small. But if it's bigger, then we simply just go through. So yeah, so we can get the high. Now we have the low bound, we have a high bound. Now among them, we have tons and tons of numbers, right? We want to find out numbers with digits, essentially, not bigger than the limit. How many numbers among all of them, right? That does not, well, with also the limit of the suffix has to be like this, right? The suffix has to be this. So we have the same suffix, then we have the lower bound, and then we have the upper bound. So if we don't look at this, essentially it's, you know, this number. So in this case, this is 0 to 4. 0 to 4. How many are within this limit? Right. In this case, lower bound is 15. Right. And we have the suffix needs to be 10. So we say, okay, lower bound is bigger than this, so we have to include a thing. Right, if the lower bound is bigger, then we include this and then put the smallest. No, put the biggest. No. We I think we do the same thing. We do the total number of digits first. So we have the total number of digits, and then we try to compare, right? And we try to make it bigger. So if it's if it's bigger, right? If it's bigger, so we probably need to go from right to left in this case, right? Yeah. So I have the lower bound, right to left. Not really. So yeah, if it's smaller than the limit, I can just push this, push it, smaller than limit, smaller than limit, right? And if at any position the value is bigger, right? The lower value is bigger than the limit, then the previous one need to change, right? And the previous one need to and if the previous one's already at the limit, then the previous one, so you have to just keep moving to the left. So we keep moving to the left until find the first one that can increment, right? Once it increment, everybody else becomes 0, right? Once it's implemented, everybody else becomes 0. But anyway, what this does is it gives us, like in this case, the lower bound basically is 1, right? And the upper bound is 215. So upper bound 215, and then our suffix is this. So we come in here, it's smaller, so we do a 2. And then we do a 1, and we do, so what if it's bigger? That is a good question. So we just, keep it. Right, so like in this case, boom, this is smaller than this. So this is the upper bound, which is good, right? So basically we have 1, 10, now we have 2, 10. This we don't consider, so we have here. But what if instead of 110, like we say like 1, 9, right? There's a 1, 9. So now I have 2, 1, 9. So 2 is good, 1 is good. Now this is bigger. So now when that happens, I need to decrease. I need to go back to the first one that allows me to decrease. Right? And once I decrease, I will move forward, then every single one will become the largest number. So this is how we decide. Right? How we decide the upper bound. So eventually we'll get something like this, right? We have this range. Lower bound is some value, upper bound is some value, with the last two the same. So now the question is, from this lower to this upper, how many do we have? Right, now basically we can include everybody in this. So how many do we have? Now I know the total number of numbers, right? Now what I don't know is, let's say, how many can we eliminate? How many can we eliminate? As long as at any position that has a value, so we know how many values from this, because this definitely is going to be a single digit, right? Some digit, some single digit, all the way to some other values. So as we go through, if we do this just linearly, extrapolate whatever this number is, and just plus one all the way to the to the biggest. We don't know this biggest it is, right? So we have a bunch of these numbers. We can try to count how many, but I feel like it might be easier to might be easier. I don't know if it's actually easier. Because I have a start, so I can go all the way to the next stop point, right? The next stop point. And the next stop point is going to be so you're going to say from this number to the next stop point. We can compute how many numbers are in between, right? We know how many numbers is in between. And can we find out how many must be excluded, or maybe how many we can include? Now the question is, I think we can, because starting from here, if I lock everybody else down, and I know how many, right? Ending at this, I know how many, and then I let this one go. I say I lock this one, I get whatever I have, right? And then I lock this one. I lock this one, I have whatever I had. But I think the difficult part is if the start and finish, the beginning and end are very close to each other. That's when I think things fall apart. Right? That's what I think. Things fall apart. Oh, this limit. I feel like I need a better use case of this limit. This limit basically just means when you count. Right? So the reason we can say, I don't know, from 100 to 199, there are this minus 100 plus 1 equals to 100 numbers. That's how we do. But now we basically just saying it will go forward at 4, right? So basically we say from 100 to 144. Or you know what's even easier, 0 to 44. How many? In decimal system, we say 44 minus 0 plus 1 equals to 45. But in cuatro system, where you count 0, 1, 2, 3, 4, and then out 5, you count 1, 4. No, you count 1, 0. Right? You just 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. And then 2, 0, 2, 1, 2, 2, 2, 3, 2, 4. Right? So now we can keep this going until like a 4, 0, 4, 1, 4, 2, 4, 3, and 4, 4. So I want to know from this to this, how many numbers in total? See, this is 4. It's just a symbol, right? It doesn't really mean anything. It's just a symbol. You might as well just think it can be like a K, right? Yeah, we don't have 14 numbers. Five, six, seven, eight, nine. Basically, I need to figure out a way to say 1 minus 4 equal to 1. This is what I need to convince. And of course, we cannot just do Well, let me see. 10 minus 4. So 10 cannot, this 0 cannot minus 4. Right, so I need to borrow 1. But when I borrow 1, right now, I borrow 1, I will multiply by 10. But now I borrow 1, I shall multiply by, instead of 10, I shall multiply by what? By 4? Now you count to 10 to go forward. Now here I can do, so you count to 5 actually to go forward. So when you borrow 1, it's actually borrow 5. Right, it's actually borrow 5. And then this one is gone, so now we have 5 minus 1, so this is 1. Which means if I want to compute, let's say 14 minus 0. Okay. Now 14 minus 0. Okay, 14 minus 0, so this is 4. Right? And this is going to be inherit at this position. Basically, it's going to be 1 times 5. Oh, it's like a binary. It's like 1 times 5 plus 4. So this is actually only 9. Right, so this should be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, because your plus 1 become 10, the count. Right? So in that case, let's say, 30, right, 31, 32, 33, 34, 40, 41. So not now we can do, let's say what we want to do is to find out a number between, let's say, 44 and 20. So I want to do 44 minus 20 plus 1. Okay, so 44 shall equal to 4 times 5 plus 4. 20 shall equal to 2 times 5 plus 0. So this is 24. This is 10. So this minus this, it should be 15 in total. We can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Boom. Right? So essentially the task becomes find the lower bound, find the upper bound. Right? We have a lower bound and we have upper bound. And expand it. Expand as a like a binary or whatever, and then we can do it. Okay, so I think I solved this. However, I need it's late, so I definitely don't want to do this. So what I'm gonna do is I'll just copy and paste the solution. Okay, I just copy and paste the solution. There should be an easier way to do this, but I don't see it. Combinatorial mathematics. Oh, that's very complicated. So is my idea wrong? You cannot do that? Okay, so I'll submit it first. Right, because it's late, but I want to just make sure that we'll go back to this some other time. Essentially, that's what it means. This is a copy paste, right? This is a copy and paste. Must do this problem again. Alright, so let's submit it. And then, yeah. And then we will reset this so I don't see it. And then we'll pretend it hasn't happened. But what really worries me is this method I did not see. That's what worries me. Yeah, that really worries me. Alright? That really worries me. So I am thinking, what if we create a, a bigger case, right? So we can say we start with, 1, 2, 3, 4, 5, right? And we're gonna end with, I don't know, we end with 1, 2, 3, 4, 5, 6, 7. That's pretty good. And maximum, let's say we do 5. Okay. I just run through this case and then we'll deal with this. Okay, we'll deal with this. So lower, so the start, right, is 1, 2, 3, 4, 5, and finish is 1, 2, 3, 4, 5, 6, 7. Okay, and our suffix is 1, 2, 4. This is our suffix. So again, so we start with 1, 2, 3, 4, 5 digits. So we go 1, 2, 3, 4, 5 digits. So the first is 1, so I can do 1. Second is 2, I can do 2. The third one is 3, but this is a 1. It doesn't work, so I have to go back, find the first one, make it bigger, and then we move forward. Everybody can set to 0, but we don't have anybody. So this is our lower bound, right? This is our lower bound. Now we're going to try our upper bound. Upper bound is the biggest, that's smaller than this. Alright, so again, we have 1, 2, 4 as this. So this is 1, 2, 3, 4, 5, 6, 7 digits. 1, 2, 3, 4, 5, 6, 7 digits, right? Again, we work from, so it has to be the biggest value that's smaller than this. Yeah, so we go 1, 2, I can do 3, I can do 4, I can do, and then this is a 5, which this is a smaller, okay? 6 is smaller, this is all small, so it's fine. But if one of them is bigger, so we have to go down here, find the first one to make it small. So now basically the question is from 13 to 1, 2, 3, 4, how many we have, right? How many we have with limit. Limit is 5. So we'll say, okay, this one is going to be, we deconstruct it. Deconstruct it. Huh. That's actually going to give you a different answer, isn't it? No, it's just, this is going to be 1 times 6 plus 3. This is going to be 4 plus 3 times 6 plus 2 times 6 squared. And then 1 times 6 is triple. Right, so this is what this one is. So we just find the difference between the two. I don't know what's the difference between the two. So 6 to the third plus 2 times 6 to the second plus 3 times 6 plus 4 minus 6 minus 3. So this will, I count to 301. So we're gonna put this to the test. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 6. So we'll go and we'll see what do we have. 302. I come up 301. Oh, plus 1. Plus 1. Right? So you do this minus this into plus 1. Talking about. Okay, this is actually has some legs. We might actually work in this case. Okay. Now let's go down something small, and then we want to get this one really big. 10 to the 15th, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we put this, let's say, 8. Okay? So this is different because small, basically, with lower bound is going to be 0. Now, upper bound is going to be interesting. So we have 1, 2, 4. And we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, technically it's 16, right? Technically it's 16 because 10 to the 15 is 16 digits. So it's a 0, or it's a 1. And then it's a 0, 0, 0, 0, 0. But then this is a 1. This is larger than the 0, so we're going to go back to make this 0 smaller. But when we make the 0 smaller, we basically loop back, right? Because we cannot make it smaller. We have to loop back to make it smaller. Okay, so we make it smaller. So we loop back. Now, if we loop back, it becomes 8, right? You loop back, become 8, and yeah, because this is just 1 is bigger than 0, right? So you have to go in the previous, because the previous is all equal. Then you try to go down, but you're already at 0. You cannot go down. If it's other things, yes, you can go down. But with the 0, you cannot go down. You go down, you loop back, right? So when you loop back, it's it's gonna look bad, right? It's bad. So you have to go previous. So you loop, you loop, you loop, you loop, loop, loop. Right? Everybody's looping. Everybody's looping. Everybody's looping. This one I can go down. So this is the biggest. It's smaller, right? Okay. So now the question is, we have 8. Right, so we have basically how many? 13 digits of 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 digits. Wait, how 12? Oh yeah, 12 digits. So we have 12 digits of 8, and then we find out basically this 12 digits of 8 minus 0 plus 1. Now this one's good, this one's good, so we just need to see how many numbers this one represent, right? So we have basically 8 plus 8 times 9, because we have 9, and then 8 times 9 to the squared, 8 times 9 to the 11th power, because of 12 digits in total. So essentially it's 8, 9 to the 11th, 9 to the 10th, all the way plus 1, right? Minus 0 plus 1. Okay, so what's that? What is that? 8 times 9 to the 11 plus 9 to the 10 plus 9 to the 9. Hold on, I think there's an easy way. 8, 7, 6, 5, 4, 3, 2, 1, and plus 1, and plus 1. Alright, so we have this number 2824 something. So we'll just run it and see what value I got. 282429536481. I solved this problem. I solved it, and I think much easier probably than what I just glimpsed on the tutorial. But again, I cannot do it today because it's too late. We'll do it some other time. I think this is actually very brilliant. Okay, I think this is actually very brilliant. Oh, I think it's brilliant. Anyway, we'll end right now, and I'll see you guys. Hopefully tomorrow is the easy one, so I have sufficient time to go back to solve this problem. I think it's very interesting, and yeah, and this ideal of ditching the decimal system, and we will reinvent it as the other system, right? You know, you just increment after 4, increment after 5. Yeah, that is the deal. But again, I'm not sure. I'm not 100% sure if it will work for all the cases. But I tested like 2. One is pretty random, right? I think both are pretty random, right? This is pretty random, and this is kind of got it really big. And this one's correct, so that gives me a lot of confidence. All right, anyway, I'll see you guys tomorrow.